All right. So with writing equations, we have some new terms, right? And those are the following. So if you have an equation, so until now we had expressions like, for example, 2x plus 3, okay? But now, if I have 2x plus 3 equals, let's say, 7, now that's an equation, right? And so like for the plus, we know that's like sum or, added to and so on. And then for the equal sign, right, there are some terms that mean equal. And those are, is as much as, is the same as, is identical to. All of these mean put an equal sign. So here, look at this one. One example is 2 plus the quotient of a number and 8 is the same as 16. So when I see this, I put an equal sign. Okay? Here, I just have the word is. I put an equal sign. All right, let's do this one. 5 times the number a squared is 3 times the sum of b and c. So here we have an is, right? Before that, I have 5 times the number a squared. So 5 times the number a squared is 3 times the sum of b and c, b plus c, right? All right, so take a look at this one. 9 times a number subtracted from 95 is the same as 37. So if I have 9 times a number, that's 9x. And then how is it going to be subtracted from 95? How am I going to write that? Yeah. So we do 95 minus 9x. Correct. 95 minus 9x. Okay, and then is the same as equals 37. Okay. Now, the sum of the cube of x and 9, okay, is identical to, okay, so now that's where the equal is going to go. But let's see what we have before. The sum of the cube of x and 9. What's that red part going to look like? Yeah.
X cubed plus 9.
X cubed plus 9 is identical to, now look, twice the difference of x and 3, right? Eitan, any ideas? So it's twice, yeah. In parentheses, twice the difference of x and 3.
Oh, difference is
right? Okay.
Does it matter if you put the add?
Yes, because if you're using difference, then you have to keep the order as is given to you. Okay? All right, let's do the next one. 13 equals 2 plus 6t. Okay, so go ahead and write that down, and I'm going to walk around. It's up to you.
When we're writing like a verbal expression, do we write the number as just like the number, or do we write the number in letters?
Either way. Again, different times I might write it a little bit differently, right? I wrote 13 equals, I went a little fancy. 13 equals the sum of 2 and the product of 6 and t. Okay, that's fabulous. The one thing you need to be super careful of is when you have this, if you say 6t, that is wrong, because 6t, we don't know what that means. You have to specify that means 6 times t. Okay, this one. 1/4, right? 1/4. And then this, like, you have to specify that it's 1/4 quantity n plus 5. So I will say 1/4 the sum the sum of n and 5. Okay, if you say 1/4 times n plus 5, that's not okay. Because 1/4 times n plus 5 also looks like this, which is very different. Okay? That's fine as well. Equals, yeah. Yeah, equals, n minus 7. All right, I'll go basic on that one. No, not distributed, times. Yes. Okay, here. Okay, so here, the difference of a and 3 not over 3, right? Divided by 3 by 2 equals the cube of a. Yeah. Okay, so we get the idea, right? Okay. Let's move on to 2.2. We're going to solve some equations. Yay. Okay. Okay. By the way, so to solve an equation, we need to find all of the values of a variable that make the equation true. In other words, you need to isolate the variable. So get x or y or m or n alone on one side. Okay. Let's talk about some properties of equality. One is the following: addition property of equality. If you have a plus b, then a plus c, a plus b equals b plus c. Basically, you can add the same number to both sides. Meaning, if you have something like this, something equals something else, to solve this, I do plus 3 plus 3. The point is, you are allowed to add, the same number to both sides, so I get x equals 8, right? We are allowed to do this because the addition property of equality allows us to do it. Okay? All right. Subtraction property is the same. If you have a equals b, then you can do a minus c equals to b minus c. So you can, subtract the same number from both sides. So here, I can do minus 5, 6 equals x. Okay? Yeah. Right. Yeah, let's do a couple of examples and you'll see. Okay? So, let's do this example number 1. I'm just going to move here for a little bit. Okay, let's do example number 1. Okay, here. You have 32 equals r minus 8. Now, the point is to get r alone. So ask yourself, what's happening to the 8? It's r minus 8. I need to do the opposite of subtraction, which is addition. Positive 8, positive 8. So here, r equals 40 or 40 equals r. Okay? Okay. Here, it's 4.2 plus t equals 1.8, right? So what am I going to do here? Olivia, what do you think I need to do here? For b. Minus 4.2 minus 4.2. Okay, hang on. So t is, right now, we're going to do this by hand, right? To subtract this, okay, when I subtract this, 1.8 minus 4.2, is my answer going to be positive or negative? Negative. So let me put the negative here. Now, to subtract, if you want to do the vertical subtraction, you have to put the bigger number on top, minus 1.8 like this. Okay? So here, this is a 2, right? You borrow 1 from here. 12 minus 8 is 0.2. So that's negative 2.4. Okay, that's how you're going to do it if you're going to do it by hand. Okay, yeah.
Do you need to write 4.4 times 4.2?
Oh, it's 2, yeah. Okay. Okay, here. What do I do? Yep, Jack. So I want to get m alone, right? What's closest to m? The 1 over 4. So what do I want to do? You subtract 1.4. Subtract 1 over 4, right? So here I get negative 6 minus 1 over 4, right? This is over 1. So that's negative 24 over 4 minus 1 over 4. Negative 25 over 4 equals m. All right. Okay, here. Kira, what am I going to do for the next one? D.
You're gonna do plus.
Okay. Yeah, so we're going to add 3 over 4. Add 3 over 4. So now let's see what I have. G equals. Now this is a little bit of a mess. So I want to write it in a way that is easier for me to solve. Right? Now I can see this a little bit better. Now, to add fractions, I need a common denominator. Between the 8 and the 4, what will be the common denominator?
8.
8. So, yeah, to make this an 8, I'm going to multiply by 2, multiply by 2. So that's 6 over 8. So that will be 5 over 8. Okay? Huh? Okay.
Oh,
Yeah, Drew. Which one? Okay, yeah. So let's do it more slowly. So, oh, mixed number? Yeah. Okay. You can, but it's like so middle school. Yeah. We like, so they're completely fine mathematically. Both of them are equally correct, but you will discover that the improper fractions, even though middle school teachers have something against them, the improper fractions actually tend to be easier to deal with when you're like adding, subtracting, dividing, multiplying them. You know what I mean? So, yeah, so like in real math, we don't really do mixed number. There's only one case in my life that I ever used mixed numbers, and that's like when we're doing trigonometry. It's a thing. I know. Yeah, it's so middle school. But middle school teachers can't seem to like get over like I don't know why they feel so strongly against like improper fractions. I don't understand. Yeah. Okay. Okay, so that's what we're doing. So here I have negative 6 minus 1 over 4. Okay? Now, negative 6 is over 1. Between the 1 and the 4, I want the common denominator to be a 4. Right? So I need to multiply this by 4 to make it a 4. And then I need to multiply that by 4 to make it a 4. Now I have negative 24 over 4 minus 1 over 4. So that will be negative 25 over 4. Okay? Yes? Okay. All right. So moving on. Let's do multiplication and division properties. So if you have A over B, you can do A times C equal to B times C, meaning you can multiply the same number to both sides. Okay? So here, look at what's happening here. Let's read this. X divided by 3 equals 8. So now if I want to get x alone, I want to do the opposite of what's being done to it. If we're dividing x by 3, now I'm going to multiply by 3 on both sides. So these cancels out. So I have x equals 24, right? So you want to like cancel out. Okay. Now, okay. So let's check this, right? Let's check. How do you know if you did it right? Well, my original equation was x over 3 equals 8. Now I got x equals 24. So let's see. 24 over 3. Is this equal to 8?
Yes.
Yeah, so I did do it right. Okay. Similarly, the division property says if you have a equals b, you can divide both sides by the same number. So you can do over c over c. So let's see. Here 2 times x is 14. If it's 2 times x, then I need to divide by 2, divide by 2. X is 7. Okay, so let's check. I have 2x equals 14. Is 2 times 7 equal to 14?
Yes.
Yes, it is. Right? So good. Okay. Now, all right. Look at this one. 18 equals W over 2. So what am I going to do? What do you think? Leo, what do you think? What am I going to do?
18
Yeah.
like multiply W.
Yeah, multiply. Multiply. Yeah.
W over 2 and then
Right. So these cancel out. So 36 equals 18. I'm sorry, W. Right? Or W equals 36. It's the same.
doesn't matter how many.
No. Let's check. 18 equals 36 over 2. Is that right? 18 equals 18. Oh my God, that is right. Okay. Here, this is a different situation because I have k multiplied by a fraction, not just a number, and it's not just being divided by a number. It's being multiplied by a fraction. What do I do in this case? What do I multiply by? Yeah. Okay, I need to multiply by 2, right? Okay. But then how would I get rid of the negative 3? Now it's negative 3 times k. What would I have to do? Yeah. Right. I would also have to divide by negative 3. So when you have a number multiplied by a fraction, you have to multiply by, what's that called? Reciprocal. Okay? We have to multiply by the reciprocal. So here too, I need to multiply by the reciprocal. Right? So now look, the 2 and the 2 cancels. The 3 and the 3 cancels. The negative and the negative cancels. So over here, I just have k. Now, this is over 1. Let's see what cancels here. The 6 and the 3, can I reduce that? By this becomes 2, this becomes 1. So k is negative 4. Okay? On the right side? So you can divide top and bottom, the 6 and the 3 by 2. By 3. Yeah. Yeah, or this would have been like negative 12 over 3, which is also negative 4. Yeah. Not that you can, you have to. If you have a variable multiplied by a fraction, to cancel it out, remember we're trying to cancel out? To cancel out, you have to multiply by the reciprocal. Okay? Yeah.
But how do you just like get two like over -3.
Okay, so this was here. What's happening to k here? Here's another way to look at it. It's k times -3/2, right? So if k is being multiplied by a number, what should I do to get rid of it? Divide. Okay. Divide by 3/2 is the same as multiply by -2/3. Okay? So if I have 6 divided by 3/2, what is that the same as? 6 times 2/3, remember? Right? So here, if I want to divide by 3/2, it's the same as multiplying by 2/3. Okay? All right. So here we go. This one, what am I going to do? What am I going to do? What am I going to do? What am I going to do for C? I am going to multiply by 3. And here too, I'm going to multiply by 3. So n is, what's n?
6/5. So yeah.
-6/5.
Yeah.
Huh?
Oh, 6/5. Oh, yeah.
Okay. All right, I'm going to give you a minute. I want you to do D, and I want you to do E. You have a minute. Go, go, go. Okay, here we're going to divide by 3. So B is how much? 28.
Oh yeah, you're right. 28. My bad.
Like, do it again. You'll get 28 this time.
Yeah, I
Okay,
just made it true.
so you're going to do it again until you get 28. Okay, so here, divide by -3, divide by -3. This time, S is it positive or negative? Positive 14. Okay, now here's another one of those examples. K times 4/5. Now k is being multiplied not by a number, not by an integer, by a fraction. So to cancel this out, I need to multiply by the what of the fraction? What's the word? The reciprocal. So that will be 5/4, 5/4. So here I get k. Okay, let's do this a different way. Instead of reducing, multiply the numerators, you get 40. Multiply the denominators, you get 36. But we have to reduce that. What can we divide top and bottom by? 4. So if I divide by 4, I get 10. If I divide by 4, I get 9. 10/9. That's it. 10/9. Okay? Now you understand. Yeah. That's it. We're done. Yeah. Okay. No. Okay. So now, you have homework. Okay, so on your lesson plan, you have homework. What homework number do we have? Wait, Eitan, what homework number is it next? 7. And you have it from 2 pages, right? Okay, that's due Monday.